Hi, so today I want to quickly have a look at one of these energy saving LED light bulbs. This model that you see here is a 220 volts model, and it's supposed to last a couple of years. This one lasted a couple of months, so I think we're going to open it up and have a look, see inside what exactly went wrong. Looking at this, I think it should be fairly easy to open. The construction is fairly straightforward. It looks like the LEDs are basically mounted on a PCB, and the PCB just slides in from the top here, and it's got one panel at the top, which is basically just a round PCB with a similar amount of LEDs on it. Okay, so give me a couple of minutes, let me work on this a bit, and let's see what I can do to open it up. The construction is fairly straightforward, as I thought. Inside it looks to be fairly messy. There's quite a lot of wiring, a lot more than I would have thought for a product like this. Let's see if we can slide these out. I suspect everything on the inside should be able to just come out. Let's just bend away all these wires. There's the control circuit on the inside there. And look, it's not mounted on anything. It's just sort of sitting there. Let's see if we can fish it out. Oh. That's it. That's all there is. Nothing else inside. Don't know if you can see in there, but it's completely empty. Apart, of course, from the wiring going down to the bottom of the lamp, where the 220 volts feed comes from. Let's just have a look where those two wires are coming in. Onto this PCB, AC. There's a component there, and the DC out there. We've got a capacitor, what is this? Another high voltage capacitor, 400 volts, and a resistor. And that's all she wrote. That's all there is. Okay, so let's take a closer look at this PCB. Right, here's a close-up of that PCB. I'm focusing on the capacitor specifically because there appears to have been some sort of an evacuation of I think what might be some electrolytic, and I suspect if you have a look at the left leg of the capacitor there, let's just get in a little closer. You can see some fluid has vented from the capacitor. Now I suspect that this capacitor is no longer functional. Let's quickly measure it and make sure that this is the component that failed. We'll also check the other components, and maybe we can even repair this light. Here's the evacuation that I was talking about. It looks like there's some sort of a fluid that's been leaking out here, and I think it's been coming from the capacitor. Apart from that, there really isn't anything else that could have gone wrong here. Let's quickly check out the component on the other side. MB6S, and that is simply a full wave rectifier. So it rectifies the 220 volt coming in to the circuit, converts it over to DC, and pushes out to the LEDs. So quite likely these LEDs are all in series, and probably we'll have a look and do some quick back of the envelope calculations just to check and make sure that you know, we are correct in our assumption that all the LEDs are in series, and then we can maybe power up one or two of them just to see if everything is still functional and working. Okay, let's quickly just measure the capacitance of these two capacitors. Let's start with the high voltage one over here. Now that's 1.5 microfarads, and the big one here. Now this should be 10 microfarads. This is a 10 microfarad capacitor. It's rated at 400 volts, and clearly something has gone wrong with this capacitor. While I was trying to measure this capacitor, I sort of realized something. It's actually the one leg there where the evacuation occurred is completely loose. So this capacitor has definitely seen better days. It's definitely not even making contact on the inside anymore. Yeah. Now I've just quickly hooked up one of these PCB strips to my bench power supply, and I'm feeding it around about 15 volts DC. And you can see these LEDs are actually made up of 3 elements. I can just come in a bit closer here. Each element effectively consists of 3 tiny little LEDs. Let's just pump up the power here. And that's actually really bright. It's the camera is doing automatic light correction at the moment, so you can't really see how bright it is, but it is extremely bright. It's illuminating the whole of my bench at the moment, and it's let me see, it's drawing a very small amount of current, so small that I can't really see it on my analog meter here. Let's see how much it's actually drawing. Now that's drawing about 5 milliamps. Alright, I think that's probably all I'm going to be doing with this lamp. It was just interesting to see what the failure mode was. Definitely the capacitor again, and also quite interesting to see how really efficient these LEDs are. As you can see, at 5 milliamps, very bright. You can't see that on the camera, but I can assure you it's quite illuminating. Let's just quickly take a look at this circuit. The AC feeds in on this side, it's labeled like that, and but the AC does not feed directly into this full wave rectifier. First it goes off to this side, feeds through the 1.5 microfarad capacitor up to the top, and then from there it feeds into the AC input of the full wave rectifier. Okay, I quickly drew out the circuit here just so that I can understand it, and it's fairly straightforward. The 220 volt comes in here. There's a 280k and the 1.5 microfarad capacitor, which I'm assuming is some sort of a filter, going straight into the full wave bridge rectifier, then off to the 10 microfarad capacitor for some smoothing, which then goes to the LEDs. The lamp itself has got 6 sides. Each side carries 6 LEDs, and that gives us a total of 36 LEDs plus 9 LEDs on the front ceiling panel, so it gives you a total of 45 LEDs. Okay, if we calculate the DC voltage on this side, it would be 220 times the square root of 2 for a pure sine wave, which gives us around about 310 volts DC. So it's still within the limits of the capacitor, the smoothing capacitor over there. However, it seems the capacitor is not the greatest quality and it failed prematurely. So there's the capacitor manufacturer. What's that? Chinks. Certainly a manufacturer of capacitors to avoid. Seems these capacitors fail often. Alright guys, I don't think I'm going to be repairing this specific lamp. I really don't think there's any merit to it. But it was interesting to see what it's made of and what it looks like on the inside. If you guys want to see more of these videos, give this one a thumbs up and I'll continue making them. Thanks for watching.